In the last video, we evaluated this 4 by 4 determinant, and we found out that it was equal to 7. And the way we did it is we went down this first row. We used the definition I gave you in the last video, where you use this first row. I could even write it here. We said that this was equal to 1 times the determinant of 0, 2, 0, 1, 2, 3, 3, 0, 0, minus 2 times the determinant. You cross these guys, cross that row and that column out. 1, 0, 2, 1, 0, 2, 2, 2, 0, 0, 3, 0. And then we went to the plus the 3 times its submatrix. I don't have to figure that out. Just cross out that row, that column. And then minus 4. We just keep switching the signs times the determinant of its submatrix. So this one had a bunch of terms, and this one's going to have a bunch of terms. Cross that row and that column out. You get 1, 0, 2, 0, 1, 2. 2, 3, 0. I'll just write here 1, 0, 2, 0, 1, 2, 2, 3, 0. And that is a completely legitimate way to figure out a determinant. And that was our definition for how to find a determinant. What I want to show you in this video is that there's more than one way to solve for a determinant. And what I'm going to show you this way is the same thing that we did down this first row, we can actually do down any row or any column of this determinant and or of this matrix. And the reason why that's useful is because we can pick rows or columns that have a unusually large number of zeros, because that tends to simplify our computation. So the first thing that you have to do before you embark on picking an arbitrary row or a column, let's say, for example, we want to pick this. Let's do one row and one column in this example. So let's say we want to go down that row instead, because we like the fact that it has a lot of zeros there. The first thing you have to do is remember the pattern. Remember, you switch signs on the coefficients. And you don't just switch signs as you go down a row. You also switch signs as you go down a column. So the general pattern for a 4 by 4 will look like this. It'll be plus, minus, plus, minus, minus, plus, minus, plus, and then you get what? A plus, minus, minus, plus, plus, minus, minus, plus. It's really this checkerboard pattern. If you wanted to figure out the sign for any ij, so let's say you wanted to figure out the sign for, this is 2, 2. So if you want to find the sign, let me write it this way. Let's say we have a function. Let me define a function. I think the checkerboard pattern is pretty clear to you, but I'll just write it down. So let's say I wanted to figure out the sign, not the not the trig identity, not the trig ratio. I want to figure out the sign of any entry where you give me an I and a j. And what you could do is you just take -1 to the I plus j power. So if you wanted to figure out the sign for the, let's say you are in row 4, column 2. Row 4, column 2. So what will it be? You do 4 plus 2. -1 to the 6th power is equal to 1. So that's going to be a positive 1. Now, if you take this guy, let's say you want to take this guy. So this is I is equal to 2, j is equal to 3. You're in the second row, third column. 2 plus 3 is 5. Minus 1 to the 5th power is -1, and you have a minus there. So that's another way to think about it. But the checkerboard pattern is pretty straightforward. So now that you have the checkerboard pattern in your mind, let's go down this row. So we start with a 2, but notice that we have to multiply it by minus, because we go plus, minus, plus, minus. So you have a -2 times the determinant of its submatrix. So you cross out this row and that column, and you're left with this matrix up here. So it's 2, 3, 4, 0, 2, 0, 1, 2, 3. And then you go, this was a minus, so then you have a plus. So then you have a plus 3 times, get rid of this guy's column and row, and you have 1, 1, 0, 1, 1, 0. That's that right there. 3, 2, 2. 3, 2, 2, and then you have 4, 0, 3. 4, 0, 3. And then you would have a minus a 0 times its submatrix plus a 0, but we can ignore those because 0 times anything is a 0. So already we've simplified our determinant a good bit. So let's see if we can evaluate this and get the same number, because only then will it be reasonably satisfying. So what's the determinant of this guy? Well, we can do it the exact same principle. We can go down any row or column that seems to be especially simple. So let's go down that row, because that row seems especially simple. So this is going to be -2. That's this -2 right here, times the determinant of this guy. So the determinant of this guy, we just have to go and say, okay, we have a plus, then we have a minus, and then we have a plus. So it's going to be minus 0 times its subdeterminant, I guess we could call it. We get rid of that row or that column and that row. So it'd be minus 0 times anything. That's just going to be 0. Plus 2. So plus 2 times the determinant, get rid of its row and its column. So it's 2, 4, 1, 3. 2, 4, 1, 3. And then you would have a minus 0 times this thing, but who cares what that is because you have a 0 times it. So that just simplified to that, which is nice. Let me write it like that. And then you have plus 3 times this thing right here. Now let's pick a nice, we don't want to do the first row. We have no non-zero terms here. Let's at least do, well, let me do this row right here for a little bit of variety. None of the columns actually seem that interesting. They all have at most 1, 0. So if we do that one right here, this is a plus, minus, plus, minus, plus. So we'll have a plus 0 times 3, 4, 2, 0. We can ignore that. Minus 2 times the determinant, get rid of this column, that row. So 1, I have to be very careful. I put this minus there, but there wasn't a minus 1 there. So let me write it like, let me make sure. I want to make sure I don't make any careless errors right here. This is a plus 1. I just do a minus 1 there to show you how things switch signs. So this is going to be a 3 times. So we're going to go down. This is this 3 right here. I lost my bearings with that minus there, but we were trying to find the determinant of this. So it's a 0 times this matrix. We could ignore that. Minus 2 times its submatrix, which is that and that. So it's 1, 1, 4, 0. And then you have a plus 3 times its submatrix, 1, 3, 1, 2. 1, 3, 1, 2. Just like that. Let's see if we can simplify this. 2 times 3 is 6 minus 1 times 4. So this becomes 6 minus 4. So that's 2. So this whole thing simplifies to 2 times 2, which is 4. 4 times minus 2, the whole thing simplifies to minus 8. Now, this guy right here, we have 1 times 0, which is 0, minus 1 times 4, so it's minus 4, times minus 2. This whole thing becomes a positive 8. And you have 1 times 2, which is 2, minus 1 times 3, which is minus 3. So you get a minus 1. So this becomes a minus, you get 2 minus 3, minus 1 times 3. So this becomes a minus 3. So you have an 8 minus a 3. So this becomes a minus 5. And then you have a 3. You have a 3 times a minus 5 right there. So 3 times minus 5 is going to be equal to minus 15. Let me make sure I got, oh, I made a silly mistake. If you have an 8 minus a 3, this is 8, this is minus 3, this is going to be 5. Very easy. Your brain starts to get fried if you do this long enough. And then you have a 3 times a 5, you get a 15. You get a 15. And then you have a 15. This term plus this term is a 15 minus an 8, which is equal to 7. Which, lucky for us, I barely evaded making a careless mistake there. We got the right answer, but this was a much simpler computation than we did in the last video. And it was much simpler because we picked the row that happened to have a lot of zeros on it. So we only had 2 of these terms instead of 4 terms like we had in the last video. And you could do the same. You could pick columns that have a lot of zeros. You just have to make sure that you always use this checkerboard pattern.